Today, we are going to work through this Unit C review together. I would highly encourage that you pay attention, you take notes, and you can't use this on the test, but I will tell you a lot of the questions are very similar to some of these. So pay attention. We're going to try to go through every single one. So number one, the vertices of a triangle are as shown. And then a translation maps point A to the following point A prime. Okay, so we have to look for the pattern and go, okay, what happened? So from -4, to -9, what happened? Well, looking at that, looks like you just go -5. And then what happened from 2 to 5? Looks like +3. Now, how did I know to look for pluses and minuses? It's because they're calling this a translation. And so that's all translations do, is just move. So I found the rules. You subtract 5 from the x and you add 3 on the y. Okay, so if I'm looking at B prime, B prime, what did I say? Subtract 5 from the x, so 6 minus 5 is 1. And I said add 3 to the y, so that'd be 9. So B prime is 1, 9. And then C, I said subtract 5, add 3, so 2 minus 5 is -3. And then +3 on the other one, that'd be 10. So looking at this, which one would that be? Looks like B. Not that bad. Pretty simple, I think. Question number 2. Ian needs to translate this triangle by this rule. What does this rule mean? This means move it to the right 1, because that's a +1. And then y -3 means move it down 3. Okay, remember this is left and right. So if it's a plus, you go to the right. If it's a minus, you go to the left. If this is a plus, you go up. If it's a negative, you go down. So what we're going to do is we're going to take this triangle. We're going to move it 1 over 3 down. So 1 over 3 down right there. Make it a little easier to see. 1 over 1, 2, 3 down. That's where my x is going to be. 1 over 3 down right there. And 1 over 3 down. So now I have my new triangle. It'd be x prime, y prime, w prime. There's x prime, y prime, and w prime. Go read and make sure I did everything it asked. It said Ian needs to translate, help him get the correct answer. I did. Okay. Number 3. Which of the following translations is needed to take ABC onto the image of A, B, and C? So how do I go from this triangle to this triangle? So what I would encourage you to do is to start with A and work your way to the other point A, or go from B to B, C to C. So what's going on from here to there? Well, you're not going left or right at all. So that's why it's going to be an X, but you are dropping it 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like the answer is going to be A. Because what this means is don't go left or right, just go down 9. And that's exactly what I did. Let's see, number 4. Describe the lines of symmetry for the letter W. So what does it mean to be a line of symmetry? For example, that is not a line of symmetry, because if you were to flip this over, you would not get W back. So that is not a line of symmetry. And I believe the only way to get a line of symmetry, get the same thing on both sides, would be right down the middle. So if you were to like flip that over that way, you would get the W back. So I would say has one line of symmetry that's vertical. We call this vertical. Okay, if it had been horizontal, it would be this way. And I don't think it has two lines of symmetry, just one. All right, reflect the figure over the line, y equals x. There is a translation rule, y equals x. The rule says, what am I doing? The rule says over y equals x, you just take the y and the x and you flip-flop them. Okay? So like W was, I'll put the coordinates down. W, we'll do it over here. W was 3, 3. Z was, and I'm talking about this coordinate here, 8, 3. Y was, to start off with, 8, 1. And X, to start off with, was, this looks like 4, negative 1. So this rule says you just take the X and you flip-flop them. Okay, so you would get the W prime, flip-flop the 3 and the 3, you still get 3, 3. Flip-flop the 8 and the 3, you get 3, 8. Flip-flop the 8 and the 1, you get 1, 8. Flip-flop the 4, negative 1, you get negative 1 and 4. So using that, I can plot those points. 3, 3 would be about right there. Stays in the same spot. Right there. 3, 8 would be right up here. 1, 8 would be right there. Oh, no, right there. And negative 1, 4 would be right there. Connect dots. Got here to here. There to there. And so really the question is, remember y equals x is this line right here. So ask yourself, does that look like it's flipped over that line? And does the shape stay the same? It does. And then technically I need to label my figure. So like this is W prime. I would label each point. I don't really have time for that because I want to make sure I have time for every problem. All right, rotate the quadrilateral clockwise. Let me think, clockwise. How's the clock move? Like this? Oh, wrong button. Clockwise means like this. Wee. Okay, that's clockwise. You don't have to say the wee if you don't want. So that's clockwise. We're going 90 degrees. And the center of rotation is the origin. Now, remember when you rotate 90 degrees, the y and the x flip directions. So like R's here is going to end up down here. S is going to end up over here. T is going to end up on the x-axis. And M is going to end up over here. So I would kind of follow the same steps. So this point is, zoom in, this point was 1, 6. That's R. And so when you rotate that, that becomes 6, 1. And then remember, so it's coming over here in this origin, everything's positive, negative. So that should be 6, negative 1. So I would go from here, that point ends up here. Okay. What did I do? It was 1, 6. I flip-flopped the 1 and the 6, and I remembered that everything down here is positive, negative. Everything down here is positive, negative. Positive on the X, negative on the Y, and that's why that turned negative. Let's go ahead and fill in the rest. Down here would be negative, negative. All the X's are negative, all the Y's are negative. Here it'd be negative, positive. And of course, everything over here is positive. All right, so now let's go to the point S. S starts at 3, negative 2. So I flip-flop the 3 and the negative 2. That becomes, and I usually just drop the sign, so that becomes 2, 3. And then I remember that down here, sorry, when it comes over here, because it's going to move from here to here, both of those should be negative. So I'm going to change that to negative and negative. So what does that mean? That means S started here, it's going to rotate, go to negative 2, negative 3, it's going to end up right there. Right there. Started there, worked its way there. Now T, that's pretty easy, because if it's here, negative 8, and go 90 degrees, it's going to end up, I mean, if it starts here, 90 degrees, it's going to end up here. That one's easy. And then finally, negative 2, 1 for M. I think that's an M. M, negative 2, 1. You flip-flop the negative 2 and the 1, and that becomes 1, 2. Again, I ignore the signs. And since M's coming over here, they're both positive. So I need to put a point at 1, 2. 1, 2. So the green dot went from there to there. All right, just to make sure I don't get confused, I'm going to get rid of these points right here and make my new shape there to there, there to there. It doesn't hurt to ask yourself, does that look like I took the shape and like turned it 90 degrees? And does the shape look the same? And my visual brain says yes, that is fine. Don't forget to label your points. Again, for sake of time, I'm not going to. Oh boy. Oh, we're just supposed to answer the question. So angles are taken at angles of the same measure. Is that true or false? That is true. So whatever this angle was here, when it went over here, it's the same angle. Okay, when you turn something, angles stay the same. Line segments are taken to line segments of the same measure. That's true. The shape does not get bigger or smaller. Parallel line segments are taken to parallel line segments. That's true. Well, parallel line segments are taken to parallel line segments. There's nothing parallel, but I would say true. And then horizontal line segments are taken to horizontal line segments. I think horizontal would take you to vertical, so I would not pick D. Okay. Number 7, you have a rectangle down here. It's reflected about SR. So that'd be reflect across there. So if you reflect over that line, then essentially you're going to get S is going to stay in the same spot, R is going to stay in the same spot, but P is going to be down here, and then Q prime is going to be down there. Then you have your new rectangle if you want to draw it. I mean, it doesn't hurt anything. So let's read it. PS, that's right here, is parallel to Q prime. So is this, so all they're asking, and I'll use yellow, all they're asking is this parallel to this? Yes, this is true. So yes, that's true. The length of QR, where's QR? Here, is equal to the length of SP prime, SP prime. So are those equal? So in a rectangle, this side equals this side. And then when you reflect it, it's going to be the same. So that one's going to be a true also. R prime is the midpoint of Q prime. Where is Q prime? So what they're asking is, here's Q prime. Is R in the middle? Yeah, it was reflected. Vertex P and vertex P prime are at the same point. Is this and this at the same point? No, that is false. Vertex R and R prime at the same point. R and R prime, remember they stayed in the same place because it was on the line of reflection, so that's true. And SR is parallel to PP prime. Let's see, SR. They're saying, is this parallel to this? No, but if they said perpendicular, I would agree with that, so that's not true. Okay, so I got A, B, C, and E. In the figure, in the triangle below, they want you to reflect twice, once in y equals 3, and then y equals -1. Which of the following would have been an equivalent transformation? I'm going to do this one real fast. So if I were to reflect this over y equals 3, and again, I'm not going to label my points, but you know, if it's 2 up, I go 2 down, so I'd label that as Q prime. And then if that's 1, 2, 3, 4, 5 up, I'd go 1, 2, 3, 4, 5 down. And if that's 1, 2, 3, 4, I'd go 1, 2, 3, 4 right there. So first to reflect it that way. And again, you should label that Q prime, N prime, N prime. So first reflect it once over y equals 3, and then over y equals -1. There's that line. So plotting my new points. If it's on the line of reflection, it stays on the line of reflection. If that's 1 under, it becomes 1 above. And if that's 2 above, it becomes 2 under. Make my new triangle. So the question is, instead of flipping and then flipping again, what else could have I done? Well, notice the black triangle and the blue triangle look very similar. It's just shifted down, like it's just shifted down 1, 2, 3, 4, 5, 6, 7, 8. So what you could have done instead is just what's called a translation. You could have just moved it. So could have just translated it. That would have been the same result. Translation. Okay. If PQ, there we are, is rotated 90 degrees counterclockwise. What do you think? Counterclockwise, clock's like this, so counterclockwise would be like that. Okay. About the origin, what are the coordinates of P? I think they mean P prime. So P is going to end up counterclockwise, 90 degrees. It's going to end up here. It was at -2,7. Make that a little larger. So it was at -2,7. So remember, my trick, P prime, is you flop the 7 and the 2 for every 90 degrees you go. And since it's going down here, Everything down here is negative, negative. So I just change that to negative, change that to negative. I get -7, -2. So that's going to be -7, -2 right there. That's where P, the new P is going to be right here. What do they ask? Oh, there it is. The very first choice. The answer is A. All right, suppose the letter I is drawn on the coordinate axis and rotated about a fixed point. Which statement is not true? Okay, the image will be smaller. That is not true. I already found the not true. If you take something, like watch my hand, and I turn it, I mean, I just made my hand go closer to the camera, but I promise you, my hand did not get bigger or smaller. So when you rotate something, it doesn't get bigger or smaller. Perpendicular segments will remain perpendicular. Parallel segments will remain parallel. The image will be congruent to the original. That is all true statements. Number 11, determine if the figure has rotational symmetry. If so, give the angle of rotation that provides rotational symmetry. I usually just start at the point, so right there, and then I try to find that point again and see, and it would go right there if I were to turn it, and then find that point again, that would be right here, and then find that point again, that'd be right here. So the formula is you take 360 divided by the order. We call this 4 because it would take 4 rotations to get back to the original. And all you do is you just take 360 divided by 4, which is 90. Super easy. That'd be this one. All right, place an X in the table to show whether the pre-image and image will be congruent or not. This is called a translation. That would be congruent. This is a dilation. It makes it bigger by a scale factor of 3, not congruent. This is a type of reflection, congruent, and that's translation, congruent. So the only time it's not congruent is when you do a dilation. What's the scale factor? Well, it looks like it was 3,2, and then it went to 9,3. So let's type that out. It started at 3,2, and then it went to 9,3. So let me think. Oh, that's not 9, that's 7. No wonder I was so confused. 7. So really the question is, how do you go from 3 to 7? Oh, and remember you take this number divided by this number. So it'd just be 7 over 3. Because the pre-image goes on bottom, image on top. So, oh, we're 7/3. Whale. I think I might be missing one. I don't think it's 5/3. I think it's 7/3. Unless I'm doing something wrong. Let's see. 3 times what is 7? 7/3. 3 times 7/3. Oh, no. Yeah, 3 times 7/3 is 7. So that should be 7/3. I'm pretty sure that's supposed to say 7/3. Okay. Which dilations will make the figure smaller? So I would change all these to decimals. That's 0.5, that's 2.6, that's 0.4. If you take a calculator and do 6 divided by 5, you get 1.2. So which ones are they? Which will make it smaller? Remember, it's any number less than 1. So I would say this one. That's half. That's 0.5 less than 1. That'll make it bigger. This is less than 1. Ignore the negative sign. This is bigger than 1, and that's bigger than 1. So I would say A and C. And then finally, we're supposed to take this image and we're supposed to do a scale factor of 1/3. So what I would do is I'd list out all the points. That's 3, -3. We'll just do it over here. 3, -3. This point is 6, -3. This point is 3, -9. And this point is -3, -6. So when we do a scale factor of 1/3, that means take all those numbers and divide by 3. So let me think. 3 divided by 3 is 1. -3 divided by 3 is -1. 6 divided by 3 is 2. -3 divided by 3 is -1. 3 divided by 3 is 1. -9 divided by 3 is -3. -3 divided by 3 is -1. -6 divided by 3 is -2. So what I'm going to do now is I'm going to plot those points right here and see what I end up with. So 1, -1 goes there. 2, -1 would be there. 1, -3 there. And -1 and -2 right there. I got from here to here. Okay, kind of hard to see, but notice the figure just got 1/3 as big. All right, so hopefully that is going to help you on the review. Good luck to you. Hope you all are successful after watching this video. I will see you later. All right, bye-bye.